All right, guys. So, once more we are meeting, and then I want to address this particular question. We talked about examining the business case of IPv6. Prior to that, there is this question that we can easily tackle, where we talk about examine and explain the rules for address allocation and then address management in IPv6. Generally, when it comes to IPv6, we need to understand that IPv6 addresses are actually divided into a unicast, a multicast, and an unicast. And under the unicast, we have the global unicast, we have the link local addresses, okay? But the IPv6 address, if it's going to be a global unicast, has a range where anything starting from 2000 colon colon going is actually classified as a global. That means that it's globally routable. Whereas anything like a link local, where you have FE8 colon colon becomes link local, which is within the LAN and is not routable. Of course, that is what is used as the next hop on the point-to-point interface for IPv6. When you talk about it comes to address allocation. If I want to allocate an IPv6 address, I have two ways to go about it. Just as we used to have in IPv4, it's either I allocate the address statically or I allocate it dynamically. Statically means that go under the interface, and of course under router point-to-point configuration, you don't want to do dynamic IPv6 address allocation using those like DHCP v6 and stuff. So you will manually configure the address, that is for address allocation. So in terms of rules for address allocation, you want to look at how it is done statically, and then also how it's done dynamically using a DHCP. And nevertheless, the IP address when it comes to address allocation, um, we looking at the entire 128-bit IPv6 address, which is divided into two for us to have the network portion, just as we used to have in IPv4, and then the host portion. By in IPv6, the network portion is 64-bit maximum, which consists of the global prefix. So the prefix is what your ISP gives to you. Okay, and based on the prefix, you can do subnetting. Most ISP, depending on your level, your tier level, you can be given a /32, a /48. Remember that we are dealing with 16 bytes in each of these radius octet. So you can be given a /60, a /32 in that order. So supposing your ISP gives you a /32, then that means that you can locate each department, let's say a /48 out of the /32. But in this place, you do not borrow any bits. In IPv6, we don't borrow any bits at all. So we can look at that structure because there's a full 16-bit subnet ID specifically for that, which I'll show you in the course of it. Is there, and then we have the interface portion. But here, the bigger goal is that now once we have that area, it's always going to be a prefix that will be allocated for the address management. So in terms of address management, we have dynamically, we have Slack. We've already discussed that Slack with stateless DHCP version 6, where we're going to provide the prefix or rights, and then the other requirements like the DNS. Maybe you want to know the NTP server for clocking and stuff. We refer you to the DHCP version 6 server specifically for that. Then we also do have full stateful DHCP version 6, where both the IPv6 and then the other records like the DNS, your domain, your NTP, all those things are fully provided by the DHCP. And in here, the DHCP exchange doesn't provide a prefix, but it keeps a state. So that's why I call it stateful. It will give you the full IP address. Okay, so that is about the address allocation. Then when it comes to address allocation dynamic, we have already discussed how Slack works, how the stateless also works, and then how the stateful works. One key thing about this has to do, if I should remember, about, yes, I've already discussed about how when you allocated the prefix, then the interface ID part, the node itself computes the interface ID part using the EUI64 or any other random generation mechanism. Of course, there are some security implications related to using Mac to generate your 64-bit interface ID. So generally, that's how IPv6 are located. We allocate IPv6 based on the prefix given, and nodes are provided based on using either static or dynamic. That is that. So let's talk about the business case. I don't think there's any other thing above it which I've missed out. Well, in terms of comparison, we've already, DHCP is in version 4, DHCP is in version 6. When it comes to version 6 only, we talk about the use of extension. Fragmentations have all been sourced from that angle. There's some level of trade-offs. Let's go straight to a business case. So, business case today is what is the business case? Why should a business migrate to IPv6, and what benefits will a business get in going to IPv6, and then all that. So there's a whole document on that about that, but to start it up, we need to view the evolution to IPv6, just as I said in my first video, as something that whether we like or not, we don't have a choice. Because the one we are dealing with exhaustion of IPv4 within the global space. And when that thing happens, and based on that, you know that Aina have already talked about the where places in Asia IPv4 is fully exhausted. No matter if you have it and you are not using it, that is your own and discard. But once we are seeing the future that 128-bit IPv6 is promising us almost 340 on the zillion IP array, which is more than the number of suns in the earth, and the solution is scalable. Everybody is migrating over there. So if you do not join the race, you will definitely going to be left out. And their services are going to come in which are going to require these things. So if we really want to talk about the business case for IPv6, the first thing we like to talk about is it's an evolution of the internet. And once an evolution of the internet, everybody must necessarily join the race. And remember that internet connectivity on IPv4 and internet connectivity of IPv6, a time is coming where you are going to have both IPv4 and IPv6 connectivity. Currently, IPv4 connectivity is greater than IPv6, but the curve will gradually exchange, where you get to a point where you're going to have both IPv6 and IPv4 being para almost equal. The amount of IPv4 connections on the internet would equal the amount of IPv6 connection, and gradually get to a point where IPv4 connection will begin to drop while IPv6 connections begin to rise. So as a business case, it is better for you to join the race as early as possible, with the first point being that it is a global evolution. Once it's a global evolution, for it to stay competitive, you must necessarily join the IPv6 race. So the first thing is about a global competition. The second thing is about the cost of infrastructure for upgrade. Once you hear about concepts like IP exhaustion, then it necessarily tied with cost, because it will then come that IPv4, getting a public IPv4 will become very, very expensive because of demand, right? For those who really don't want to go to IPv6. Whereas IPv6 IPs will be readily available at a very substantial and very low cost. So your cost of infrastructure upgrades, if you are doing infrastructure upgrades, which is something that we always do, then it is wiser to factor IPv6 in your upgrade plans. Anybody doing an upgrade for the next 5 to 10 years must necessarily implement IPv6. Otherwise, after your 5 to 10 years, you'll be forced to come to the drawing board again to now implement IPv6 as part of your infrastructure upgrades. In the industry, we upgrade our backbones, we upgrade our access node, we upgrade almost everything, software-wise and all that, your data center, all that. So you necessarily have to implement IPv6 in such an upgrade. And then the other thing we talk about, so I talk about the first thing is evolution of the internet will demand IPv6 is a business case. The second thing is that the cost of infrastructure upgrade which we do will be lesser if we factor in IPv6 at an earlier stage. Okay. The third thing is that we will be driven to IPv6 by applications. There are applications that sees IPv6 as the only way to function or to work. There is this DOCSIS, DOCIS 3.0, which is an evolution which is allowing the cable television stations to not only provide TV services but also provide internet services through that same connection. And because TV is mostly multicast services, and IPv6 plays a better role, a better function when it comes to multicasting compared to IPv4 implementation of multicast. Almost all the DOCSIS solutions require IPv6. So if you have a customer that needs to support DOCSIS or any other of this kind of services, for example, in the MMTC, which is a massive mobility connections for 5G, you realize that the IPv4 addresses that we have is not enough to sustain this MMTC requirement, just like the ultra low latency. Generally, in terms of 5G, so IPv6 with this 340 on the decillion will be the best solution in this case. So the third point for business case is that we are going to be driven by applications. Applications will drive us to change our infrastructure to support or to upgrade our infrastructure to support IPv6. Then the other thing is that the fourth thing is that what will drive us is if we really want to avoid the time pressure. So the time pressure is where we've not had enough exposure to the IPv6 environment. We have not started implementing or planning our IPv6 or upgrading to IPv6 earlier. Then we are caught up in the midst based on the demand of our customers, based on the demand of these modern services. Network slicing, all those segment routing is something that is done on IPv6 more scalably. So we will get to a point where we will hit an under pressure. And once you're under pressure, it's something that we will not recommend for any solution architect, because once you find yourself over there, you'll be hit with where you've not had enough time to expose yourself to the architecture. You've not had enough time to get your lessons learned, and it's going to cost you. The risk is so high. So 4 points I leave you: evolution of the internet. 2, infrastructural upgrades that we have is a business case to deploy IPv6. 3, applications will drive us to deploy IPv6. 4, the need to avoid being under pressure for IPv6 is also a business case for us to deploy. So let us quickly go through this book. I could highlight some key points, just to remind us of all these 4 things that we've done. And we'll be done, then move to our planning for IPv6. So this book is reference to I think it's Sylvia. Yes, Sylvia. Planning for IPv6, and it has a part called chapter 1. It's about the business case. Okay. So we go. So it says that the first thing is that every decent engineer who has mastered the introduction of DHCP, VPNs, NAT, that is purely an IPv4 expert, should also be able to easily master IPv6. That is true. We say that. However, there's a caveat. The caveat is that when it comes to IPv6, our understanding of subnetting, where we slice very, very small, we make sure that we are giving what the network demands. So we slice it very, very small. That perception that we have in IPv4 of slicing packets in smaller chunks, that is the only thing we don't want you to bring to IPv6, because of the nature of how IPv6 works. IPv6 tends to have a prefix. So if you do that, you begin to bring the same limitations of IPv4, where nothing and all those things have to come. Remember that in IPv6 we are not doing that. So come here with a bigger chunk, slice for your network, because we are not borrowing any bits from the other. So you'll be fine with it. Okay. So that is what it said. And then say that the process can get into a single or double steps. So just the process for that. And then here it's talking about that generally when we talk about a business case, we're saying that we are looking at what are the benefits or the risks to the business as we begin to go in terms of cost and then in terms of the benefits, right? And then what might qualify as a substantial case in one corporate environment, not necessarily. So we're just trying to gives you an overview of what goes into um, developing a business. But then all businesses do understand that using scalable high performance network is key. That means that all businesses require their network to grow. So if you want your network to grow, then IPv6 is the way for it to grow, because we know that IPv4 cannot sustain us fully for the future, despite the NAT and all those kind of, it's an evolution. I always say that for example, nobody knew that the world we are going to use cars. We used to use horses. Okay, and nobody knew we were going to use cars, and nobody didn't even know that how to even plan our roads. But when demand came, the human intelligence was able to find a solution around. It's the same thing happening to IPv6. The demand is there. So definitely, if you're investing in your networks to evolve, you must consider IPv6. Okay, and also in terms of the human, so this is just giving a case scenarios. In terms of the human factor, I always do recommend that it is better to start IPv6 transition early. For example, using dual stack, we'll discuss dual stack. So dual stack is where you have both IPv4 and IPv6 available, and we suggest that do this while you have enough IPv4 in your network, because dual stack requires both IPv4 and IPv6, and gradually be turning off your IPv4 based on traffic usage or service usage, right? So I think there's something funny here that Einstein said that I said that no problem can be solved from the same level of consciousness that created it. So in other words, for us to solve the problem of IPv4, we cannot sit in IPv4 and solve that problem. We need to sit outside IPv4, which is IPv6, to create. And I fully do agree with him that no problem can be solved from the same level of consciousness that created. That's interesting. All right. So some creative developers, well, is just giving us trend, this all trend, right? So if you want to talk about the business case of IPv6, then we're saying that without the introduction of IPv6, the internet cannot continue to grow. And everybody agrees with that. Now that IPv4 address space is definitely exhausted, this means that everyone who uses and profits from the internet has to do his part in helping integrate IPv6. Integration too will have to be a global collective collaboration, of course, because the internet is peer-to-peer connection using BGP. So once part of it, like Asia has gone IPv6 already, so to communicate with Asia, it is better for it to go IPv6 end to end, less latency, less all those overheads coming for those who push for NAT64 in their network and etc. So some corporate cultures, this might be a sufficient case. So once the internet is going, it's a sufficient case for us to go, right? And then some will say that IPv6 has no immediate, it has no immediate business case, but it will soon catch up with us, and it's already here, right? So we're saying that the evolution, extension, optimization of our network infrastructure always came at a cost. Here, what it's saying is that now businesses, whether you like, we expand our infrastructure, we put money to upgrade our infrastructure to meet current demands of our customers. Okay, we do upgrade, software upgrade, hardware upgrade, build infrastructure, the connections and all that. We expand our network. That's why we have a planning team. So it is better for us to incorporate IPv6 now into our planning, into our network upgrade infrastructure. And that was what I was talking about. In other words, evolving our network has always been part of our returning budget. As the services running on top continue to consume more bandwidth, we have to replace network. So it's giving examples of why when we do upgrades based on service demand. So once we have that scenario, it is also wiser for us to incorporate IPv6 demands in there. So the business case, it would definitely not in the router or the operating system you are upgrading, but to know that if we don't upgrade to the current versions, right, the devices or operating systems will perform poorly or fail some points, and or we won't be able to run new services on top of it. So this just supporting that point of we having to have infrastructure upgrades has been the key thing. The often result is improved capability. Well, we just giving an example. So let's continue. I guarantee that applications. Okay, so there's the second part where we say the third part where we say the applications are going to drive us. So you're saying that the applications and services will be developed that will only run on IPv6. And I give you an example of the Doxy. Because they will use new features of the protocol that cannot be run on IPv4 network. Typical example of said protocol I talk about is, in IPv6, there's an extension header called the routing header. Protocol, it uses the next header value is 43, and that header allows us to program the path that the route should take. And that is the core for segment routing in IPv6 in 5G architecture, where we program the hops and which packets which routers should go through the packet and then work on the packets like that, and it streamlines the packet and all that, reducing the number of routers that have to function on it. So once you have not been programmed to work on the packet, you just allow the packet to pass through, exit out of your network, right? So these are packets that will drive, these are services that will drive us, and there are many services. So as an university or as an industry, it is better for you to upgrade your core or your backbone, get yourself ready for IPv6 with dual solution, awaiting service demands, right? So business case will definitely be in the application services that will soon require IPv6 or need so many IP address that IPv4 cannot handle them. IoT is a typical example. Massive machine-to-machine connections is also a typical example. Integrating IPv6 under time pressure creates many disadvantages. So that is the last thing I want to talk about. Don't go under time pressure. What are the disadvantages? It takes about 3 to 5 years to do this transformation to IPv6, and you want to do this in a risk-free and a digestible way. You want to carefully build, secure, and manage your robust network, and also to educate your team, prepare your team ahead of time. Once you have IPv6 running in your backbone together with IPv4 as dual stack, and you are not passing services over it yet, you have enough time to see how they work. You can create sample services on your own within your own confines, and then troubleshoot, look at how the routing table, OSPF, BGP, and then all that functions around it, right? So so that's also another thing. We're saying that content delivery, mobility, industrial networking is also going to drive these demands. Okay, so that was the Doxy 3.0 I was just referring to you about, right? Okay, so implementation of Doxy gives cable companies a competitive advantage over legacy wired broadband providers, and enabling them to provide services ranging from voice over IP, multi-band, high definition television to internet speeds over 100 Mbps through channel bonding. And this best is done with IPv6, Internet of Things, also by IPv6. So, what will you lose if you don't invest in IPv6? Well, you just know it. We are in a world of competition. So managing secure extending IPv4 infrastructure will become more and more costly. It's a fact. It will become more and more costly. People will based on your demand Okay, and vendors, every vendor also had end of support of life for their devices, for their software order. It will get to a time where IPv4 will be turned off. Okay, and state of the art applications with high performance requirements may not work well on the IPv4 infrastructure. So there are a number of reasons. Of course, we could also lose our market share once we are unable to provide the services that support the infrastructure. So the Internet Protocol I version 6 compliance products be included in all information technology. That is something that the United States Federal Acquisition Regulation talked about. So it become an enlightenment on us to make sure that the devices that we are deploying do support IPv6. And then we will lose the opportunity to play IPv6 with careful planning and with step-by-step integration. That still boils down to making sure that we do not deploy IPv6 under time pressure. Start it early as you have enough time with you now. Start with your planning phase. Understand your current traffic flow with IPv4. See your ISPs for an IPv6 block. Start deploying from the core to edge because that is more safer. You have full control over your core. By the time you get to your edge, most of your customers that you provide services to would have been IPv6 ready, and that would be much more better. So core to edge. In some cases, people want to talk about isolated cases where you have a small network which will be IPv6 only, then you could tunnel it to another IPv6. There are a number of transition solutions we will discuss later on. So generally, I think this is what I just want to show. An investment in IPv6 is an investment for the future technology, very important. And whereas it is important to note that investment in IPv4 is an investment in an end of life technology. So it will end. So you don't have to keep investing so much in here, and the cost is going to go high per demand. Okay. So it's important because build knowledge experience, but we will eventually have to do this anyway. So why not start now? Okay. So let's go. Where do we start? Where does time pressure? Well, time pressure we already talked about when there's pressure on you. Where, for example, time pressure, we look at where you already have lack of IPv4. We can just write that down. IPv4, that you don't have any other choice than to go IPv6, and you haven't done enough studies, you have not even done enough. In that way, even dual stack becomes an issue. You want to go IPv6 only. Also, when your customers or applications are driving you, it will also put you under very huge pressure. In terms of internet growth, you reach a limit if where you support only IPv4, you cannot do much. You will not provide optimal internet performance and lacks the advantages of a true end connectivity, including meaningful access and statuses for the website. So in terms of internet connection, it is going to be IPv6. You don't want to be putting at 64 and that's one because that also adds overhead and processing delay. We are entering a world where latency is key. So as much as we want to deploy IPv6 end to end, right? So generally, if you're running IPv, oh, and this is also key. Whether we like it or not, IPv6 is already running in most of our networks, especially in the client side. They already turned on by default. Once you turn on an IPv6, once you turn on your laptop or PC, start soliciting for IP addresses already using Slack. So generally, and then the concept of IP eyeballs, that RFC also helps a lot. Get that done as soon as possible. During planning, you will get a good picture of what is required for the different parts of your network, so you can define milestones and then time. We will actually enter into what the planning phase will be like. What are the opportunities of IPv6 integration? Of course, you know it already. This is the best for the future. Many lessons could be learned as you do that, and then you will be ready when the whole world is fully ready, is actually deploying And doing IPv6, you want to be concerned about your addressing schemes. You want to be concerned about your network and routing scheme. You want to be concerned about how you're going to do network management. You want to look at security. So you have certain security features already built into the layer 3 IPv6 protocol using the extension headers, which you can leverage on and then use as compared to IPv4, where we had to rely on application layers and the transport layer for security, okay, firewalls and stuff. But this time on the layer 3, it's even possible that in IPv6 you may not. It's just a guess. It is my own perception. I haven't seen it anywhere because IPv6 extension headers support full IPsec and all that. You can easily encrypt your data and do all that with your packets without not necessarily having an external device. And I foresee a future where the concept of firewalls will be merged with the layer 3, the routing layer of it, and IPv6 will to support it. So as packets begin to come in, you can actually program what kind of policies the packet should follow. And I think this is something that in segment routing, SRv6B, SRv6 policy routing, these are cases um, where we already programming this kind of behaviors that we want a packet to exhibit into them already, right? Okay, so how safe is your money when you integrate IPv6? Well, so here, so we're trying to say something that if you ask customers and customers are talking about that, oh, I have a plan to upgrade my data center in the next 12 months. I'm redesigning my DMZ in 2 years. Anything that starts between now to 5 to 10 years, you must necessarily consider IPv6 as part of your overall infrastructure. In that way, you will save the future cost now. Okay, and as you leverage more of your stuff into IPv6 and ensure your infrastructure is supporting IPv6, you are better off and you are left off the hook of the conflict of IPv4 exhaustion, the politics around that and all those kind of stuff. So you fine. And if you buy a new core router next year, chances are yes. So definitely, and we will get to a point. Your DMZ is actually where you face your internet. So that is what. And generally, when you also doing outsourcing, so companies will also like to outsource their infrastructure, the management of their infrastructure, the deployment of their infrastructure to a third party. In discussing such solutions, you must necessarily talk about IPv6 as part of it. So in a summary, the key thing is IPv6 is inevitable. We could be under time pressure, which we all need to avoid. Okay, and IPv6 is the future. So the business case of IPv6, in a summary, we are talking about that it is an evolution of the internet. Everybody is going there because of the exhaustion of the IPv4 environment. It's also going to be the business demand is as you do it right now, you do a cost savings, and because you factor it as part of your infrastructure upgrades already. The third business case is that applications, which is the driving force, services, which is the driving force of our businesses, would demand the use of IPv6 based on the type of services that they rely on, which IPv4 cannot support. We give typical examples of Doxy, we give typical examples of segment routing, coding, and all that, right? And then also the fourth thing we talked about is that the time pressure. To avoid the time pressure, no business wants to know about the cost or the risk associated with time pressure. Time pressure is a scenario where you are not fully prepared for the evolution that is coming, and it hits you bam, and you have to overhaul all your infrastructure. You need to hire technical experts to quickly deploy or upgrade to the IPv6 infrastructure for you. Your people have to be quickly trained. It's all haphazard. This is something that we do not recommend for anybody. We want people to have enough time. Plan yourself as you have enough IPv4 now, and then plan IPv6 along starting from today to the next within 2 to 3 or 5 years, you should be able to transition your backbone network into IPv6 and then begin to consider about the edge using the various IPv6 transition mechanisms related to dual stack tunneling protocols like the ISATAP, the 624. There are a number of tunneling, even in MPLS, there are lots of tunneling protocols to support this kind of transition. Then you can talk about translation using NAT64 for legacy devices which have no support to IPv4, but yet IPv6 needs to communicate direct with IPv4. So thanks for that. That is the business case I have for you. Enjoy your day. I will come back for us to discuss the next one, which we'll be looking at. Hmm, okay. So you look at best practice for planning your IPv6, and then what are the available transition mechanisms, which we also talk about, right? All right. Thank you, guys. Enjoy your day. Bye.